How does garbage collection in V8 work in the context of asynchronous code? V8 uses a generational garbage collection strategy based on reachability analysis. What exactly exists is a heap divided into young generation and old generation. A root set, including the global object and active execution contexts, and internal runtime structures that store references to asynchronous callbacks. When asynchronous logic is scheduled, V8 stores references to callback functions inside promise reaction records, timer registries, or event listener tables. The causal chain is a sync task scheduled, callback stored internally. Callback references lexical environment. Lexical environment references objects. Objects remain reachable. As long as an object is reachable from the root set through any reference chain, it cannot be collected. V8 frequently runs minor garbage collection on the young generation to clean short-lived objects and promotes surviving objects to the old generation. If asynchronous callbacks or closures keep objects alive longer than expected, those objects survive multiple collection cycles and are promoted to the old generation. Objects in the old generation are collected less frequently because major garbage collection is more expensive. This means long-lived asynchronous references can increase memory usage and trigger heavier collection cycles. V8 does not treat asynchronous code differently in terms of logic. It only evaluates whether objects are reachable. If a promise never settles or a timer is never cleared, the callback remains referenced and memory cannot be reclaimed. For a software engineer, this means proper cleanup of asynchronous resources is required to break reference chains and allow V8 to reclaim memory efficiently. Garbage collection in V8 works by tracking reachability, and in asynchronous code, objects remain alive as long as callbacks or internal async structures reference them.